Now let's understand why Redis is lightning fast. So first point is that everything happens in RAM. So let's see the capabilities of RAM first of all. So I mentioned one table. So there are 3 rows of RAM, SSD and hard disk. So let's see the speed. If you want to perform any operation, Redis will take or RAM will take approximately 100 nanoseconds to perform that operation. If you have to do the same thing in SSD, it will take 100 microseconds. In hard disk, it will take 10 to 5 milliseconds. So this is the difference. So hard disks are still in use with some legacy systems. SSD are still in use and everyone is using in databases. But if you want something at very high speed, like if you want to perform operations like million operations in a single second, then of course you have to go with Redis. And Redis will provide approximately 10 million plus operations in a single second. While SSD can also perform like 500 to 100k operations in a single second, that is also a very good number. But if you talk about the hard disk, it will be able to perform only 500, like able to perform approximately 100 or 200 operations in a single second. So it's not that good. But if you want to perform anything very fast, you will of course choose Redis. Just remember one thing, that if you're choosing Redis, you will get a very good speed. But the only problem is, if you want a lot of space, then you have to pay a lot of money for it, because you're getting speed but the space that you're getting on RAM is going to be very less. Now let's move to the second point. So second point is single threaded and event driven architecture of Redis. So first of all, let's understand the single thread. It means that Redis work in a single threaded architecture. So I mentioned, like, suppose there are 3 clients, client 1, client 2 and client 3, and there is a Redis. And I told you that Redis are going to store the data in a form of a key value pair. So I mentioned that key is going to be counter and value is going to be 0. So what happens now? Suppose that if client 1 come first, then client 2 and client 3 are going to wait, because Redis is a single threaded architecture. Only one action can be performed and all the other tasks has to wait. So client 1 is going to, let's say, increment the value of this counter variable. I also mentioned counter plus plus. So let's say client 1 is going to increment the value from 0 to 1. So all the other clients, client 2 and client 3, are going to wait at that time. Now what will happen after that? Then the client 2 will going to perform the action, then client 3 is going to perform the action when the client 1 has completed its action. Remember one thing, that Redis is going to follow a FIFO format, first in first out, or you can just say FCFS, first come first serve. Now we are going to see event driven architecture or non-blocking IO. These are both same things. So let's understand it. So what I did, I just put one while loop on all these clients. So let's understand it. So suppose there is a one client, client 1, and it is performing some action on Redis. I know that Redis is very fast and every action will take just a microsecond or a nanosecond, but let's assume that client 1 is taking a lot of time in performing any action. So the client 2 and client 3 are waiting. But if there is a while loop running, so let's understand like a code. If a while loop is running, if the client 1 is perform any action, is fine. What will happen? Then client 2 will come and it will check if Redis is free or not. If Redis is free, it is going to perform the action. It will also increment the counter. If Redis is not free, don't worry. What will happen? It will just go back into the queue. The order is going to change because client 1 is still busy. And now what will happen? Now the order is going to look something like this. Client 1, after that client 3, and then client 2. Because what will happen now? Client 2 will go back into the queue because client 1 is still busy. So what will happen to accuracy? Let's understand it. Suppose client 1 is going to set the value 1, client 2 is going to set the value 2, and client 3 is going to set the value 3 in this counter variable. So suppose if the order changes, so first client 1 is taking a lot of time and it sets the value equals to 1, but the order changes. Now what will happen? Now the counter will change to, let's say, 3, and after that 2. This is done by the client 3 and this is done by the client 2. So don't you think the accuracy is going to hamper because of this while loop, this non-blocking IO, because of this event-driven architecture? So the answer is yes. The accuracy can hamper because of this event-driven architecture, but this is only possible when Redis is going to be slow. And Redis is going to be slow in some of the scenarios. Like suppose that there are going to be 100 million operations in a single second, then we can say that Redis accuracy is going to hamper a little bit. One more important point is that this event driven architecture is also used by Node.js servers and Nginx. So it is also one saying that Node.js server is not used with very big projects. This is the biggest reason, because if there is going to be a massive load. Now let's move to the third point. So Redis is a data structure system. What do I mean by this particular sentence? So Redis stores the data in a form of string, integer, list, and many more. We are going to see them. So in a normal case, like if there is a string, so Redis will store the value, let's say key, and the value is going to be string. If it is going to be integer, Redis is going to store the value key, and the value is going to be integer. Now there is one question for you. Like suppose there is a one value equals to key. It is in string, of course, and the value is going to be 123, and it is in double quotes. Like it's an integer value, but it's in string right now. How will Redis going to store it? Now let's move to the third point, list. So in Redis there are multiple kind of lists. So first point is zip list and quick list. If the we can just take a simple example. If the data is less than 512 or 500, we can just say let's store the data in a form of an array. But if the data is going to be more than 500 elements in a single list, we are just going to use the concept of doubly linked list to store the data, so that we can easily able to traverse. If the pointer is on, like suppose xyz location, we can just simply insert or delete operations can be fast. That is why engineers have made zip list and quick list inside the Redis, so they can perform the actions on the basis of data size. If that size is less than 500, let's store it in an array. But if it's greater than 500, we can just say let's store it in a form of a quick list. And this 500 is a dummy number. I'm just giving you an example. Same with sets as well. In Redis, suppose in sets, if integer element, Redis has said if there are the elements in the sets that are going to be a proper classes or objects of Java or C++, Redis is going to use hash sets. And if there are only integer elements in the set, Redis is going to use inset. So it is designed in a way so that it can increase the speed of the system. There are sorted sets as well in the Redis. To sorted set supports priority queue, leaderboards, something like that. Now there is one important point in Redis, that Redis supports streaming. Streaming is like a time series database in Redis. So suppose there is a key, and you can just store the value like this is going to be a timestamp, and this is 0 timestamp 1 timestamp 2. So this type of time series database helps to store the state of an onboarding. You can say you can just store the history of an orders. This time series data is also helping Redis to act as a Kafka at many cases. We'll see that as well.